the night sky has always been a source of wonder and awe for humans. As we gaze upward, we see a tapestry of stars scattered across the darkness, like countless diamonds strewn across an endless canvas. There's no denying the beauty of this celestial spectacle, yet there's something that doesn't quite add up when we consider it more closely. Despite the fact that there are potentially trillions of stars, each one burning bright and emitting vast amounts of energy, the night sky appears overwhelmingly dark. Why is it that, even though the universe is teeming with light sources, the cosmos seems predominantly black? This question, which has intrigued astronomers and stargazers for centuries, was famously formalized as Olbers Paradox, named after the German astronomer Heinrich Wilhelm Olbers. His paradox raised a question that has confounded scientists for generations. Why is the night sky so dark, even though there are countless stars in the universe? In this exploration, we'll dig deeper into this question and uncover the fascinating truth behind why the universe appears dark, despite the brilliance of the stars scattered throughout it. Imagine for a moment that you're standing in a large, dark room. The only light sources in the room are a series of small LED lights scattered throughout the space. If there are enough of these lights, they would illuminate the room and fill the space with light. Even if you only had 20 or 100 of them, the overall effect would be significant. However, when we step outside and look up at the night sky, we observe a very different phenomenon. Despite the trillions of stars in the universe, the space between them appears dark. How can this be the case? The answer lies in several fundamental concepts about the nature of light, the structure of the universe, and the vast distances that separate the stars. The idea that the universe is filled with light, yet appears dark, can be puzzling. After all, the stars are not just faint glimmers. They are blazing furnaces, emitting unimaginable amounts of light and heat. Yet when we look into the night sky, we see nothing but darkness. It seems counterintuitive that with so many light sources, the sky isn't awash in light. The key to understanding this paradox lies in the nature of the space between the stars, the distances that separate them, and how light behaves in the vastness of the cosmos. If we think about the light from the sun, we know that it only illuminates the Earth because the atmosphere scatters the sunlight and causes it to reflect off the surfaces we see. Without this scattering, we would not experience daylight as we do on Earth. When we look away from the sun, toward the stars, the darkness we observe is not caused by an absence of light but rather by the fact that the light from distant stars is too weak to illuminate the space around us. Imagine a flashlight in a dark field. If you stand alone with a flashlight, it will shine brightly around you. However, as you walk farther from your friends and their flashlights, the light becomes less effective in illuminating the entire field. Even though there are multiple light sources, the vast distance between them means that each individual light source does not have a noticeable effect on the environment around it. Space is vast and virtually empty. In fact, between stars, there is an enormous amount of empty space, with light years separating the closest celestial objects. There is no atmosphere to scatter the light, no surfaces to reflect it. This lack of matter to interact with the light causes it to travel through space without illuminating the void. Light can only be seen if it interacts with particles or objects that can scatter it, such as the atmosphere of Earth or the surface of a planet. In the vacuum of space, the absence of such particles means that light travels unimpeded and remains invisible until it reaches something that can reflect or scatter it into our eyes. In essence, the darkness of space is not due to a lack of stars or light sources, but because the space between them is empty and light cannot interact with anything to make it visible. This idea leads us to the famous paradox that Heinrich Wilhelm Olbers posed in the 18th century. Olbers was curious about the night sky and asked why, if the universe was infinite and filled with stars, the sky wasn't bright all the time. His paradox can be framed simply: if the universe is infinite and filled with an infinite number of stars, why doesn't the night sky appear as bright as the surface of the sun? Olbers believed that if the universe was static and infinite, then every line of sight would eventually encounter a star. Thus, the sky should be fully illuminated. But this was not the case. The darkness of the night sky seemed to contradict the assumptions about the infinite number of stars that must exist. At the time, the concept of an infinite and static universe was the prevailing model. People believed that the universe had no beginning or end, and that the stars and planets were fixed in place, with no change occurring over time. Olbers and other thinkers of his era did not have the knowledge that we now possess about the true nature of the universe. For example, they were unaware of the vast distances between stars, or that the universe itself was not infinite but rather expanding. They also did not know that light from distant stars could take millions or even billions of years to reach Earth, and that some stars were so far away that their light had not yet reached us. If Olbers had been able to peer into the future and witness the discoveries of modern astronomy, he might have come to a very different conclusion about the nature of the universe and the reasons behind the darkness of the night sky. The expansion of the universe, as we now know, is a key factor in understanding the darkness of space. In the early 20th century, astronomers like Edwin Hubble discovered that galaxies were moving away from us, and the farther away a galaxy was, the faster it was receding. This discovery led to the formulation of the Big Bang theory, which proposed that the universe began as a single point and has been expanding ever since. As the universe expands, the light from distant stars becomes increasingly redshifted, meaning it stretches out into longer wavelengths that are no longer visible to the human eye. In addition, some stars are so far away that their light will never reach us, due to the accelerating expansion of the universe. This realization, that the universe is both expanding and not infinite in age, provides us with a crucial piece of the puzzle when it comes to understanding why the night sky is dark. Now that we have a basic understanding of why the night sky is dark, we can further explore the true nature of space and the light that traverses it. Interstellar space, the region between stars, is not entirely empty. While it is true that space is mostly a vacuum, it is not completely devoid of matter. It is filled with a very thin distribution of gas, dust, and cosmic particles, which are spread so sparsely that we can hardly perceive them. These particles are what give rise to phenomena like cosmic rays, which are high-energy particles traveling through space. In addition to these particles, there are magnetic fields that stretch across vast distances in space. The density of these particles and fields is so low that they have almost no effect on the way light travels through space. This lack of matter in interstellar space is why we don't see anything other than stars and galaxies. In terms of visual appearance, interstellar space is not truly black, but rather dark. If we could somehow illuminate this vast emptiness, we would likely see a range of colors and structures that are currently invisible to us. For instance, the planet Pluto, which resides far from the Sun, appears dark and difficult to see from Earth because it is located in a region where sunlight is very weak. Yet, thanks to recent space missions like NASA's New Horizons probe, we now know that Pluto has a range of colors and surface features that were once hidden from our view. Similarly, if we could illuminate interstellar space with light, we might discover previously unseen structures and patterns that are otherwise hidden in the darkness. However, the real reason why space appears black has to do with the way light interacts with the vast emptiness between the stars. The darkness we see in the night sky is not caused by the absence of stars or the absence of light, but rather by the lack of matter in space to reflect, scatter, or absorb the light. Light travels freely through the vacuum of space, and because there are no particles to interact with it, it does not illuminate the space around it. This is why the night sky, despite being filled with stars, remains dark and seemingly empty. Another intriguing aspect of this discussion involves dark matter, which makes up about 85% of the total mass of the universe. Dark matter is a mysterious substance that does not emit, absorb, or reflect light, making it invisible to our instruments. Its presence is inferred from its gravitational effects on galaxies and other large-scale structures in the universe. Some have speculated that dark matter could be responsible for the darkness of space, given its pervasive presence throughout the universe. However, dark matter is not dark in the sense that it blocks light. It is dark simply because it does not interact with light at all. Its invisibility contributes to the overall darkness of the universe, but it is not the cause of the cosmic blackness we observe. Finally, there is the question of why astronauts, even when in the vastness of space, sometimes report not seeing stars. This phenomenon, known as starless space, is partly due to the extreme contrast between the brightness of objects in space, such as the sun, and the surrounding darkness. When astronauts are in direct sunlight, their pupils constrict, reducing their sensitivity to faint light sources like distant stars. Additionally, when astronauts are aboard spacecraft or space stations, the bright lights within the craft can also diminish their ability to see the stars. Cameras used by astronauts to take pictures of space often have settings optimized for bright objects, which means that stars, which are much fainter, are often not captured in photos unless specific adjustments are made. In conclusion, the darkness of space is a result of the vast distances between stars, the lack of matter to scatter light, and the behavior of light itself. The universe is not dark because it lacks light, but because there is no matter to make the light visible to our eyes. The night sky, with its endless sea of stars, is a reminder of the infinite and awe-inspiring universe that surrounds us, and while it may seem dark at first glance, it is far from empty. The mysteries of the cosmos continue to unfold, and as our understanding deepens, so too does our appreciation of the beauty and complexity of the universe we inhabit.